Polar graphs allow us to do a ton of different types of shapes, and one of them is a rose graph. And rose graphs, or rose curves, are curves formed by the equation r equals a cosine n theta, or r equals a sine n theta, where n is greater than or equal to 2 and n is an integer. The reason they're called rose curves is because they look like petals on a flower. And you can graph a rose curve by evaluation if you want to take a bunch of theta values, plug them in, find out what 8 times sine of 3 theta is, and then plot each of those points separately. You can. And what we're going to do is we're going to do that first. I've set up already what these points are. So 0, 0. At 30 degrees, we're at 8. At 45 degrees, we're at 4 squared to 2, which is just less than 6. Then we're back at 0. Then 90 degrees, negative 8. So negative 8 down here. Then we're at 135 degrees, 4 squared to 2. 150 degrees is at 8. 180 degrees back at 0. 210 degrees at negative 8. So that's here. 225 degrees at negative 4 squared to 2. 240 degrees at 0. 270 degrees at 8. 300 at 0. 315 at negative 4 squared to 2. And 330 at negative 8. So vaguely what this graph looks like, I said that they were petals. It's like this. And then actually what's happening here is that we'll go down here and then curve back. And that's what the rose curve looks like. But how would we graph this without having to go through this process of plotting each point separately? Well, first we want to draw the circle r equals a. So in this case, that circle would have been this circle with radius 8. And it's going to be, the rose curve is going to be inscribed in there. Then, if the function is sine, we're going to plot the point a, so 8, 90 divided by n. So 90 divided by n, that was this point. If it's cosine, we're going to plot the point a, 0. If n is even, we place 2 n points evenly on the circle. If n is odd, place n points evenly on the circle. So we have 1, because n is 3, we're going to place them 3 places evenly on the circle. So what I mean by that is, because a circle is 360 degrees, they're going to be 120 apart. So 120 apart from 30 is 150, another 120 is 270. Then we inscribe a rose curve with each petal touching the circle. So, woof, woof, woof. Okay, so let's do that with this. First, we're going to draw the circle at 5. Second, because it's cosine, we'll start by plotting that point. Because n is 6 and it's even, we're going to plot 2n points around the circle, so 12. Because we have 360 divided by 12, that means that we're going to look at things that are 30 degrees apart. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Great. So now we inscribe a single petal for each of these. So there is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 curves. There we go. That's our rose curve. Here, we're going to start with our radius being 2. Because it's sine, we're going to start from 90 divided by n, which is 45 degrees. We're going to place 2 petals that are evenly spaced, so half of that is 180 away. 180 away from 45 is 225. And now we can describe, oh, sorry, I'm sorry. We're going to place 4 petals. So they're 90 apart because n is even. So now we have 1, 2, 3, 4 petals. That's our rose curve. Lastly, here, because 5 is even, sorry, 5 is odd, so we're going to have 5 petals. Here we had 4, here we had 12, here we had 3. 6 tells me that the radius of the circle is 6. I'm going to start by placing it at 0 because it's cosine. And we're going to go 360 divided by 5 apart. So 360 divided by 5 is 72. So 72 degrees apart. So we have 72. 144 would be the next angle. Then add another 72. Add another 72. And now we have 5 evenly spaced petals. And that is our rose curve. Thanks.